All right, students, so welcome to the next part of our transformations series, which we started last lesson yesterday. Today, we're going to focus on your log transformations. Yesterday, we learned about your squared or quadratic transformations, where we squared the EV or we squared the RV, okay, on our list and spreadsheets on our CAS. Okay, so instead of squaring, this time we're going to learn how to use the log function, so logging transformations. So here's a scenario: the rate of immunizations on whooping cough and rate of deaths by whooping cough is recorded in a number of countries. So this is the immunization rate, and these are the deaths. All right, so what we need to do is put this data in a spreadsheet and then apply a log transformation to the immunization rate, which is the EV. So this is your EV. Make a log transformation to this. So putting that on our CAS, I've done it earlier already. Here's my CAS. I've put my immunization rates. I've called it ImmuRate. Just make sure that you understand what you've called it on your CAS, as that will help you to obviously put the transformation in. So if I want to do a transformation, I'm going to go, I could call it whatever I want, but I might call it log immu, okay? No, log ImmuRate. So on my CAS, go down to the second row here underneath the transformation. So, and you're going to press equals log log in brackets, and then type in the name of the EV, which I put down as ImmuRate, IMMURATE. And if you did it correctly, it should turn like this, or it's bold writing. So press enter, and now don't fret. Yes, that's what it looks like. That's totally fine. Okay, so we've applied the transformation to this. Now, just as a quick side note, before I continue on, I want to show you guys the difference between an untransformed data. So this is my old log ImmuRate data. Notice how it's sort of curved, but if I transform the, at least I'll do some sort of transformation. So in this case, I did a log transformation on the ImmuRate. It is a little bit more linear than what it was before. Probably could be better, but that's okay. It's more linear than what it was previously to that. So that's a bit more curved. Here, sort of pushes the data a bit forward and makes it more linear. Okay, so there's my log transformation. Next is I need to write down the equation of the least squares regression line. So there's a couple ways you can do this. We've been doing that through our lists and spreadsheets. Okay, so let's do that. So we go, put your cursor there, menu, statistics, 414, 4. Okay, here I remember, put in the transform data because we did transform the X variable or the EV, which is log ImmuRate. And on the RV, we'll go death rate. Okay, so remember for your formula, let me make this a bit smaller. Okay, remember on your formula what the form looked like. Yeah, it was, let me write it here. Y equals A plus BX, and you're changing A and B in your formula. So that's where you get A and B from. Yep. Also, just double check to make sure that you got the numbers right when you write them down by just putting your cursor there so you can see what the numbers are. So there's A there. I'm going to write my formula. Y equals A, which is 5340. Now it does say here we need to round to the nearest whole number. All right, so watch out for that. So that's 5340. Let me fix that up. And then the B, or the gradient in this case, is negative 2715. Okay, I'm writing it to 5 because that 7 will affect that 4. So minus 2715x. There's my formula. Okay, nice and easy. Now the next part is we need to make a prediction on what the rate of death is going to be if the immunization rate, so if X was 80%, and then we need to round this to the nearest whole number. So on my calculator, okay, you're going to go solve. All right, Y equals 53. Ooh, one thing I did forget, sorry by the way, is that the X variable should be log X. Okay, because remember, we made a transformation on the x. All right, so in this case for b, you need to use your solve function, yeah, because we're going to figure out what's y if x was 50. So it's going to be solve y equals 5340. Okay, take away 2715 times the log of, and we're looking at 80%, right? So 80, and then comma y. Okay, so let's put that in our calculator. Okay, so solve bracket y equals 5340, take away 2715, multiplied by, so times the log of 80, close that bracket, and then and then comma y, close bracket. Oops, I think I forgot to put a bracket there. There you go. And if you get that, you can press Control Enter, and there's your answer. Okay, what's the death rate? So don't get too confused with this, because we did get it right. It's just, I think the calculator, there might be a setting that you need to do to make it so that you get this. Okay, and don't be like me, don't forget to put the brackets in the right spots. We'll do another example of this for the next question, but again, there's your answer. So y equals 173.11. 173. Actually, we can leave it as a whole number, because it does say leave in answer to the whole number. And if you look at this, for 80, 80 would fall between basically 78 and 85. And according to the rule, well, we made a transformation, right? So there's going to be some sort of difference between the numbers. So there it is. Okay. Let's continue on to the next one. But I'm going to skip this, and we'll do a transformation instead on the RV. Okay, because it's the same question. So let's check this out. So same scenario, but instead of doing a transformation on my a log transformation on my immunization rate, it's going to be a log transformation on the death rate. So on this. All right, so let's go back to this. Also, as a side note, in case you've forgotten, you can actually also get your formula if you go into your list and spreadsheets. Or yeah, here, data and stats. So I've put already my transform data there. If you just go menu, analyze, regression, and then a plus bx, there's your rule there. It's the same as the rule that we had initially there. Okay, except remember, I did round it because it does say to round to the nearest whole number. All right, so that's another way you can do it, but we'll just continue on doing it here. All right, so get rid of your transformation and any other data they don't need. Okay, remember for part A, we're going to do a transformation of the RV this time, so the death rate. Now, just to recap what I called it death rate. So that means if I want to do a transformation on it, log bracket death rate. Well, actually, I'll do that after. I'm going to call it log death rate for now. Do the name first, sorry, and then go down. And now we press enter, equals. And then you go log bracket death rate, and it should go bold if you've written it correctly. Enter. So now it's done a log transformation on the EV, which is the death rate. Okay, now if I look at my data again, you can make a comparison and see what the transformation is going to look like. So we've done a log death rate now. Yes, so I think it looks like the log death rate is probably a better transformation than the log IMU rate. But what if you did a transformation on both? Let's see what that does. Ooh, see, so that's sort of the next level where we do transformations on both of the variables, but we won't go there today. Okay, let's just stick to one transformation at a time. All right, so from there, you've done your transformation. You're going to now look for your rule. So you go menu, statistics, stat calc, linear regression. So we're going to leave this as normal because we didn't transform X this time around. but we did transform the y variable, which is log death rate. Okay, so there's my rule. All right, so let's write it down. Remember, your rule form should be y equals a plus bx. So there's a, there's b. Put that in your formula. A is 3.969. It does say to 2 sig figs. So I want two important numbers. That means this is going to become 4 or 4.0. Okay, because that 9. I want two important numbers, so 3 and 9. That 6 will affect the 9, which affects the 3, so it becomes 4.0. Plus, well, this is going to be a negative 0.0217. So that'll be minus 0. I want two important numbers, 0. That's just a placeholder. But if there's a 0 after the decimal on the right side, it's important. So here it's going to be 0.022. Okay, because that 7 affects the 1, x. Okay, one thing that Torio forgot again is to make sure you put log on what variable you transformed. So don't forget to put log y as the part of the formula. Sorry guys, y. Okay, so there's my formula. Now, the question here for part B is use your equation to predict the death rate by whooping cough in a country where the immunization rate is 60%. Round your answer to the nearest whole number for this. All right, so we're looking for, again, what is y if immunization rate was 60%. So we're going to go solve. Oh, actually, let's start with this. B, solve log y is equal to 4.0 take away 0.22, 0.22 times what did you say, 60%, and then comma y. Okay, so let's put that in our calculator. All right, so it's going to be solve. Okay, log y, put that in brackets, yeah, don't forget, equals, okay, 4.0 0.22 multiplied by 60, comma y, because we're looking for the y variable. In this case, y is equal to 478.63, rounded to 479. Cool. All right, and that's basically it for your log transformations. Thank you.